So, you've built an AI agent, that's awesome, but what happens when you need to go from one agent to a whole fleet of them? We're talking about systems where thousands of agents need to work together. And that leap, well, it brings up some massive architectural challenges. Okay, let's dive into this.
Right, this is the big one. How do you make sure your system can not only scale, but is also tough enough to handle the real world? How do you keep this powerful fleet from just spiraling into total chaos? So, in this explainer, we're going to break down 5 key patterns for building a really solid agent fleet. First, we'll hit 2 patterns all about scaling, handling huge demand and directing all that traffic. Then we'll dive into 3 patterns for making your system resilient, making sure it can bounce back from failure and even learn from its mistakes.
All right, our first pattern is all about being flexible. This is the secret to handling those wild, unpredictable workloads without breaking a sweat or your cloud budget.
You've probably run into this. If you don't have enough agents running, you get these frustrating bottlenecks and everything slows down. But if you have too many, you're just burning cash on resources you don't need. Trying to guess the right number ahead of time? Yeah, good luck. It's almost impossible. So the big idea here is that the system manages itself. Think of a busy grocery store. They don't just guess how many checkout lanes to open. As soon as the lines get long, boom, another lane opens up. This pattern does the exact same thing, but for your AI agents, and it's all automatic. And the way it works is actually pretty cool and simple. You have a message queue, and it starts filling up with jobs to do. Once that queue hits a certain size, a threshold you get to set, the auto-scaling system just kicks in. It instantly spins up new agents to chew through that backlog. And, just as important, when things quiet down, it scales back down. It's dynamic, it's efficient, and you don't have to lift a finger. Okay, let's look at pattern number 2. So thanks to auto-scaling, you've got the right number of agents. But now, how do you send work to the right agent?
Just imagine, an app needs to get an agent to process an order. It looks out and sees your whole fleet, but it has no clue which ones are busy, which are free, or maybe which one is specialized for that kind of task. Just picking one at random, that's a total shot in the dark, and it's super inefficient.
The solution is this gateway. Think of it like a smart traffic cop, or maybe the host at a busy restaurant. It sits between the outside world and your agent fleet, grabbing every single request and routing it to the best possible agent for the job. This makes sure every task gets handled as fast as it can.
And it's super important to get this straight. These 2 patterns aren't an either-or thing. They're powerful partners. Auto-scaling is like changing the size of your team based on how much work there is. The gateway is like the team manager handing out assignments to the right person. You really need both for a system that performs at its peak.
Okay, we've covered scaling. Now let's switch gears and talk about reliability. Our agents often have to rely on external tools and APIs, and let's be honest, those things can be flaky.
This is just a massive waste of time and resources. The agent gets stuck, just hammering a service that isn't answering. It's like endlessly redialing a phone number you know has been disconnected. It doesn't just waste that one agent's time, it can actually drag the whole system down with it.
The name really says it all here. It works just like the circuit breaker in your house. When there's a power surge, it trips to prevent damage. This software pattern trips to protect your system. It keeps an eye on the failure rate, and if it gets too high, it just tells the agent to stop trying for a little while. And this is the really smart part. When everything's good, the circuit is closed. If too many failures happen, it flips to open and immediately starts blocking new requests. But it doesn't stay open forever. After a little while, it goes into a half-open state, where it carefully sends a few test requests. If those succeed, great, the circuit closes and we're back to normal. If they fail, it's back to being open. It's a really intelligent way to fail fast and recover gracefully.
So a circuit breaker is great for those big outages. But what about the little stuff? Those annoying temporary glitches like a network hiccup or a service that's just busy for a second.
No way! Absolutely not! If your agent just throws in the towel after one failed attempt, your system is going to be incredibly fragile. A second later, the network might be fine. We need a way to handle these little blips without having to write a ton of custom code for every single action.
And that's where a good retry module comes in. It doesn't just blindly try again, it's smart about it. You can set it up to try more times for, say, a critical payment than for a simple status update. You can control how long it waits between tries, and, crucially, it knows when to quit. If it gets a permanent error, like a 404 not found, it stops immediately so it's not wasting any more time.
But hang on, retrying stuff can be dangerous, right?
What if the first request actually worked, but the confirmation got lost? You do not want to accidentally charge a credit card twice. And that's why idempotency is absolutely critical. By giving every single request a unique ID, the system on the other end can recognize if it's already seen that ID before, guaranteeing the action only happens once, no matter how many retries you send.
All right, let's get to our final pattern. This one is really cool because it turns what used to be a dead end into a chance for the whole system to actually learn and get better. So what happens when the message itself is the problem? Maybe it's malformed or the agent trying to handle it hits some weird error. If you just keep retrying it, it's going to fail every single time and it'll just clog up the works. This is what we call a poison message.
The classic solution for this is something called a dead letter queue, or DLQ. After a few failed attempts, the system just gives up and shunts the poison message over to this special queue to get it out of the way. And usually a human engineer has to go in and figure out what went wrong, but this is an AI system. We can do better.
And this is where it gets really powerful. We can create a special remediation agent whose entire job is to watch that dead letter queue. It can analyze the failed message, figure out the root cause, and sometimes even fix the message itself and resubmit it. It can ping other agents for help, and most importantly, it can feed information back to the whole system so that that same error doesn't happen again. This turns the DLQ from a message graveyard into a self-healing automated improvement engine.
So, when you put it all together, you see how these 5 patterns are designed to work as a team. Auto-scaling and load balancing give you the scale you need, while the circuit breaker, the retry logic, and this automated remediation give you incredible resilience. Together, they take a simple group of agents and turn them into a truly robust, enterprise-grade system.
And that really leaves us with a fascinating question to chew on. We're building systems that don't just do things, but can actually diagnose and fix their own problems. As this kind of self-healing gets more and more advanced, what new possibilities, what new levels of autonomy is that going to unlock?